No, okay. Again, if you have a question, please place it in the chat room and raise your hand so I can see who's asking what at a certain point. Marcos will be your instructor for today. That's all for me. Marcos, the floor is yours.
Hello, everybody. Today we will do the third Tinkercad webinar and the last one. This is the webinar that we are going to design actually things that you can use for visually impaired people. First of all, since most of you designed the clocks, and send the clocks to us, I will take a moment to try to show you the three out of all of them that I chose, and I decided to share it with you in order to talk a little bit about them. And then we will move on. We will talk about how to cut or to slice an object in two. And you will see why we will do that, and then we will go on and design 3D objects for visually impaired people. So without further ado, let me share the screen. Let me share my screen. Okay, put that here. Okay. All right. So let's go to the first clock. Let's see it all together. Okay. So I will not tell the names because we haven't asked anyone about if they want to share their name. So we will just say it together. This is the first clock. As you can see, somebody tried to make, let's say, a clock for the hand. And also, instead of putting a random square here, he also wrote something down. So he used a text, and you will see what the text can do. You can actually write things down, design what type of font you want, and if you make it a whole, you can make something like that. So this is a very beautiful design. If you actually put a list there, you can put it in your hand. Okay, and clock number 2. So this is I wanted to show it to you because basically this was the most beautiful one. I would actually 3D print it and put it on my wall. As you can see, it's very close to what I did. The circles here, the 4 numbers, they are actually placed on top of a of an object, and yeah, basically that's the best design, the design, let's say, I would choose to go. And the last one is this one. So what I wanted to show here is that, as you see, the person who did it didn't make a circle. He actually made another type, let's say, of of shape, and you can actually do that either by rotating, as you remember, with the stairs. You can do this part here, let's say. You can do this part or this part, a triangle, and then just go on and rotate it, rotate it, rotate it, and duplicate it. Okay, so by duplicating, you can make this very interesting design, or you can actually use another shape. Now, okay, now I think that this one, this type of shape, this the big one, may be actually a shape on Tinkercad. So maybe the person who designed it just stole it from Tinkercad and placed it there. But either way, you can either do it like that or the way I told you to. And yes, so basically, I don't want to take any more time to talk about the clocks. I want to congratulate everybody that spent their time in order to make something like that. So I saw a lot of things. I saw some fun stuff, and I actually saw very interesting designs like those that I show you. And now let's go to the main course. Let's all log in to our Tinkercad account. And start creating a new design. So the first thing that I'm going to show you today, as I told you before, is how to slice an object in two. And why would I want to do that? First of all, let me place the object first so you can understand what I'm going to talk about. Come on. That's weird. Okay, for some reason my computer is lagging. Okay, perfect. Okay, 1 minute. All right, so this is the Astrobot, the Astrobot 2, or that's how they call it. So in order to print the Astrobot, if you want to print it, the slicing program will tell you that, you know what, I can't actually print, let's say, this hand here, because this hand here needs a support like that. And I need to design a support like that to print it. Because if I start printing here, it may fall. So let's say that I want to avoid that. What could I do? I can either place it somewhere like that. Hold on a minute. Somewhere like that. So it prints from the beginning from here. Or I can cut it. I can cut this part here, just a hand, print it, and then glue it back together. So let's forget about this hand because it wasn't a very good example. Let's think about the legs, for example. So if I start printing the legs, I need a support here. I also need a support somewhere here. And of course, as I said before, a support somewhere here. Okay, like that. And let me keep that here for reference. So in order to make the print faster, because supports needs also time to be printed, I can actually cut the Astrobot in half. And how do I do it? I drag a box and place it on the feet, let's say, of the Astrobot, like that. I want my box to fit the whole Astrobot. As you can see, I click on the top here, on the upper left, and I fit the whole astrobot like that. You can actually click, did you see that? You can actually click on the orthographic view to be sure that the astrobot is inside. What I want to say here is that I always prefer the orthographic view from the perspective view because it helps me understand exactly where the objects are. But you can also choose perspective view. It doesn't really matter. So what I want to do here is cut it in half, and I am the one who decides how to cut it in half. What I want to do is cut it somewhere here, and now what I will do is duplicate the whole box. So click duplicate while you have the whole box. See, this is here right now, but you also have to check the height, which is 34 millimeters. So right now what I want to do is just move my box 32 millimeters up. 37, I'm sorry, 37 millimeters, like that. And again, I will place my box back to my astrobot, like that. So now, if I duplicate the astrobot, so I just instead of clicking, then shift clicking, then shift clicking, you can actually just drag your mouse and do that and duplicate all of them together. And now you have two astrobots. And maybe you have imagined how I'm going to do this. I'm going to delete one box from the one astrobot and one box from the second astrobot. And if I group the first astrobot with the first box and the second astrobot with the second box, I have my astrobot cut in half. And now, if I want to print it, I can rotate it. And as you can see now, let me show you. Right now, this part can be printed without any support, and the only support that I need is, oh, sorry, is this one right here. So instead of printing that much of a support, now I can print my part with a small support or maybe non-support and glue it together. So this was the first thing that I wanted to show you. If you have any questions, guys, you can ask now because we're going to move on to our second part. Maybe also write it in the chat, whatever you want.
Marco?
Yes.
Okay. I think it would be good to explain to all participants about the support because, you know, many of them are not very familiar with the 3D printing process. So maybe they have some questions about what support is for 3D printing.
Okay. I will explain it to you again, guys. As I remember, Thanos, Jolie mentioned the supports. No, Julie, didn't you mention the supports on the?
I'm not sure. I try to think about it,
Okay,
but I'm not sure.
okay. I'll speak a little bit about it right now. So basically, what happens? Let me okay, let me go back to the presentation. 1 minute, guys. Let me see what I have. Okay, maybe this, okay. Forget it. Let me just show you some pictures. All right. This is a very informative picture right here. So when my printer prints, it starts printing from the first layer, then the second one, then and we are actually talking about the FTM printers, guys, not the other type ones. The FTM are the, let's say, the cheapest ones and the most easy to find and use. So I print layer by layer by layer by layer. When I reach this limit, after this point, I can still print, but um, it's let's say it's not that safe now because I start printing on the air. But when I print the next layer, the thing is that when I have, let's say, 30 degrees slope here, when I have 30 degrees slope, I can still print because it's close to my previous layer. But when I print like this at a 60-degree slope, it's very easy to not print on the previous layer. And what will happen is something like this. Something like this. So this is a T, the letter T. And at this photo, at the right one, as you can see, we put supports, and so we can print it. But here, since we have 90-degree slope, I cannot print on this part. So it falls down and my print fails. So basically, for those of you who don't actually who didn't know what support was, this is what it is. So this is another very informative photo. As you can see, when I print the letter T, I need support here to print it because it will fall, as I showed you before. But when I print the letter Y, since the slope is small and I print layer by layer, I have no problem printing it. Yes, and that's all. I hope I covered that matter. I thought Julie talked about it. I'm really sorry.
Okay,
Okay.
Marcus,
I'm
don't worry.
sorry,
There's
I
no problem.
really don't remember. I'm sorry.
In any case, so if anybody has any question, okay. So Pia just asked. Hold on a minute. So Julie just
Yes.
you
Answer.
answered. Okay. Okay. Let's move on. Uh, So the next thing that I will go through is how to import and export your files and send them to people. Just to inform you guys how you will do that stuff. We will go fast through that. So first, we will talk about importing files. So when I have a file and I want to import it, there are some ways to do it. I can either import it as an STL or an OBJ file, which is basically a 3D model file, like the one you see in front of you right now. But you can export that file from any type of design program. Well, not any type, but most of them. And so this is basically very self-explanatory. What I want to do now, and I want you all to do that, because if you design to print things, that's what you will do 50% of your time, is go to Google, write down Thingiverse, which is the most common site from finding design, not the only one, but the most common from finding designs to print. And well, since it's Christmas, let's go to the reindeer right here. And now you can go here, download all files, click on this, wait for 5 seconds. Okay, that's weird. Let me
Marcos,
yes,
that is
yes.
not weird. This is something that really happens to Thingiverse the last days. Maybe
Ah,
you want to try not to download them all. Go to the download
okay.
things and you will find it just a little bit further. Yes.
Okay, thank you,
Oh,
Yuli. Thank you very
yeah,
much.
yeah.
Maybe I download through here. Okay.
Yes.
So they may have a problem with the servers, as you said, guys. There is no problem. When you do it, let's say on the next week, most probably there will not be a problem. So I have this one here. I hope this is the design. So this is an STL file, my prancer.stl. I can click import, choose a file, the one that I chose on the Thingiverse. Oh, let me also show you that you can actually go to the search part and search whatever you want. Let's say I want to find an elephant. The Thingiverse will try to find some elephant files like this one here, or like there you go, or like this one, the pink one. So whatever you want to design, maybe I want to design a box. I don't know. I want to print a box or design it. You can find so many things here, and also except the Thingiverse, there are more 3D printing uh, sites where you can find free 3D models and either redesign them or print them. Like my mini factory, for example, .com. In any case, let me go back. So as I told you guys, you click import, choose a file, and find your STL file, and just click open. Now a new UI comes up that asks you how do you want to import it, in millimeters or in inches. We choose millimeters because most of us are European. And on the dimension, on the scaling, you don't really want to change the dimensions because it will reshape your model. What you want to do is change the scaling. So if my dimensions are small, maybe I rescale it to 200% to make it double of the size. But as I can see right now, it's a very nice, it has a very nice dimensioning. So I will just import it. Let's group all those together and put them on the back.
Marcos, if I may.
Yes, yes, yes.
Vangelis Terianakis has a problem seeing where to download the files from Thingiverse. Could you show him
Yes,
again? Thank you.
of course, of course. Since we are also waiting for importing the file. So here you can click on any picture. You can, let's say I want to find an apple. Okay, I write apple. And now, okay, now it, it finds Apple products. Okay. In any case, let's say I want this Apple iPhone stand. So I click on the picture. It redirects me to the site, and I can click on right here. Click download all files, and it will download every file that will that is on this that James Declercq designed. So this is what you do. You just actually click download, and this comes up. It says download the files in 2.1, and it starts downloading files. I believe that it will direct me to an error right now. So if you have a problem downloading, if you did that and you have a problem downloading, it's because there is a problem. Oh, no, it actually downloaded the file. But in any case, if an error comes up, this is because, as Yuli said, there must be a server problem, which will be fixed, I hope, at the next week, maybe. So, yes.
I'm trying to download it, but you did something else before. You press download all files, and the 404 error came up, and then you did something else. What did you do?
Okay.
To download the file.
Yes. So you can, let me show you. So here that we are on the stand, you can click here that says think files. This one. I will click now. And now you can see each file separately and download them separately. So if this error comes up to you, maybe you can try this one. You can try downloading them separately. So Vangelis, please try to do it. And if you have any problem, let's talk about it at the end of the lesson, maybe, so we can continue. So, wow, still importing the file. That's weird. So any other, all clear now? Okay, perfect. Okay. That's weird. Let's wait for a minute, guys, because let me actually talk about that. So if your object is not that simple, let's say, it's not just a box, it's more complex, it has more shapes on it, generally it's has more complexity on the design. It may take a lot of time to import it, because right now what Tinkercad is trying to do is trying to translate it, let's say, and import it to the program. And the more complex your file is, the more time it will take. In any case, I will try to find a simpler file just to showcase. Let me actually import one of the clocks. Okay, let me import one of the clocks. So it's not gonna be that Christmassy. Ah, no, it will be. Okay, so the file just got imported. As you can see, it got imported with the support here. In order for you to not add support, just start printing. And right now, what I can do is I can move it around. So the same things that I can do with a box, that I can move it around, the same things I can do with my reindeer here. Let me make it bigger. Okay. And also I can reshape it. So I can either do something like that, because maybe I want to put the reindeer on the wall and make it slim, or I want to make it I want to make the reindeer higher. So you can manipulate it the same way you can manipulate a box. You can group it together with a box the same way you can do with a box. And generally you can use it as a shape. See, this is one thing right now. You can use it as a shape. You can do whatever you want with the file that you import. So this is how you import and manipulate a 3D file, guys, when you want to play with it, let's say. And the way to export it is just click on export. And now, since I haven't clicked on anything on my design, here it shows me include everything in the design. So I can decide which type of file I want to export. As you see here, I can export OBJ, STL, or GLTF, which are 3D files, or SVG, which is a 2D file, and it is for laser cutting or other purposes. So let me click here. And what happens now on the bottom left, it says preparing model for export. And hopefully it will start downloading it here. So let's say that I don't want to download all of them. I just want, okay, so here it is, guys. It's just here. It's already downloaded. Ingenious Cassie. See, this is the same name that my model has right here. So let's say that I don't want to print all of that. Instead of deleting the astrobots behind, I can just click on the reindeer, click export, and now I have another option that says include the selected one. So I can either click on everything in the design, which will do exactly what I did before, or just click the selected shape, and again, you can either download it as an OBJ or an STL. And again, it prepares for export, and you can export. And now I will export the reindeer, just the reindeer, nothing else. And the last thing that you, wait a minute. Okay, and the last thing that you can do is send files. And what I want to show you guys is either you can click here and send them to the Fusion 360 because it's browser based. It's a browser based program. You can send it to your account, but this is a little bit more advanced. You can actually send it to Thingiverse or my mini factory. So you design something and you can share it with the community, or you can invite people. So if I click here and click generate a new link, now it generates me a link. I can create copy link, linked copied. So I have a link now. So if I paste the link here, I can click and go on my design. This is my design right here. So I can actually share the link. I can copy and paste this link through an email or through anything else. And if I want, let's say, to share it with a friend, he can click on the link and dive into Tinkercad and maybe redesign what I designed, or change the color of what I designed, or add something. So we can actually work together on a design and share it and talk about it and collaborate. So these are the three things that you can do: import, export, and send to. What I want to do is talk about a little bit more about the importing of files, because yes, you can import a 3D file, but you can also import a 2D file. You can import an SVG file. So SVG files are basically 2D files that I can find on the internet, download them. For example, I can click freesvg.org. For some reason, internet is not helping us today. Okay, and there are so many pixels. So the same way I can search here on my toolbar on the Thingiverse, I can also search on freesvg.com. Find, let's say, this mouse. Okay, this mouse is nice. So I can click on the mouse, download my SVG file. Here it says download SVG. Find it on my downloads and maybe put it on my desktop. Okay, I will call it mouse.svg. All right, and the same way I imported my reindeer, the exact same way I will click here, choose a file, but instead of choosing the reindeer, now I will click on the mouse.svg. There it comes up. Again, a UI comes up, and I can either click on center of the art or artboard. That is not that important. Scale, again, the same thing. So this time, as you can see, the scale, the 100% scale is a little bit big because it's 300 by 300. So I will rescale it to 50% and import it. So your question is, since I have a 2D file, what will happen? Basically, it's still a 2D image, but in 3D. And this is the final product. This is your 2D image in 3D. So I can find an image like that and make it a 3D object and print it, guys. And you may ask, why would I do that? This is where I come and we start talking about helping visually impaired people with this tactic, because let's say that you want to teach someone how to how the world looks like. So I will make a new design for this. So maybe you can find an SVG file that has the world and print it and let them touch it. But you can also import it as a URL. So what I want to do here, αυτό μπορώ να το βγάλω, το πάμε πιο πάνω. Talk to like that. Okay, this is better. So what I want to do is what we were trying to do all this time is import shapes like that and find the file and import it. But what if I told you that you don't have to download a file at all? You can import it from the web directly to Tinkercad through a URL. So how do you do that? You click here, you click Google Images. So basically, you can find any image that you want to. Just click on Google Images. And this is the search for Google Images. And let's say that I want to find a world map. I also write on the end of it SVG. So the Google will understand that I will want something with an SVG file, and as I click it, a lot of pictures come up. So as you can see here, beneath from the photos, it says world map, let's say low resolution, from commons.wikipedia.org. I hope you can see that. Let me, can I go closer? See, it says world map commons.wikipedia.com. Again, world map with Arctica, commons.wikipedia.com. So from commons.wikipedia.com, you can find a lot of things and either download them like this one, or just go here and click original file. Just click on it. And now it redirects you to the file. This is just the image. And this is the link of the image, upload.wikipedia.com, blah, 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 .svg. And if I copy that, Control C. Click import file and paste it with Control V and click import. Let me rescale it to 30%. There I go. I directly import it through the web without downloading anything to my computer. May need some time. Give it a minute because I need to show you something very interesting in my opinion. So how much time did that take me? It took me 1 minute. It took me 1 minute to go to the web, write down worldmap.svg, find it, and there it is. There I have the whole 3D world map in my hands. And what I want to do now is find a box, make it like that, make a height, let's say, of 2 millimeters, put it somewhere like here, maybe change the color because I don't like red. And like that, I can actually take this and print it. And why not? This is the first thing that you can do without any trial really of designing things. Now you can actually print that and show somebody who has a visual problem, let them touch it with their hands and understand how the world looks like, how the continents look like, how the countries are separated by each other. Let them have an understanding of how the world is shaped and how a map looks like. So this is the first 3D model, guys, which took us 2 minutes to model it, because basically we didn't model it, we just imported it. And now what I will do is start actually designing from zero. Before doing that, I will stop for 1 or 2 minutes, wait for some questions, and then go on.
So raise your hands or unmute yourself or write it down to the chat. If you have any question. No, I see no questions here, Marcos.
Okay. So let's start designing then. So the first thing we're going to design today is a 3D diagram, a 3D plot diagram, which will help a visually impaired student understand how a plot diagram works. So we will put the x-axis, the y-axis, we will number the axis, and we will try to put pins on top of the diagram, so somebody that can touch it with their hands can understand how a diagram works. So for those of you who are following me at this process, I will try to not go that fast. Okay. So for the outer diagram lines, the first thing we have to do is drag a box and change its dimensions. So I will change the dimensions to 120 Where did it go? Ah, so okay. This is not the dimensions. These are the dimensions. 120 by 5 by 6.
Marcus,
again,
could you
one.
repeat, sorry, could you repeat what are you going to show us now?
Yes, we are going to design the 3D diagram project. So let me show you the end result, so people will understand what I'm talking about.
Yes, thank you.
So this is the end result that we'll end up with. Since I don't like, I'll make it green because I don't like red. So as you can see here, this is an X and Y axis plot diagram that you can number it with 1, 2, 3, 4, 5. And here are the pins that you will print. And maybe take a pin. As you can see, there are holes on the diagram. All these are holes that we're going to design. And when you print the pin, you can actually take it and hold on. You can actually take it and put it on top of it like that, like that, like that, like that. And let's say this is the X equals Y diagram. And for a kid, this is a very good way to let them play and understand how a plot diagram works. So this is basically y equals 2 plus x, right? No, x equals 2 plus y. Anyway, so I hope I covered that. I covered what we're going to design.
Yes, thank you.
And let's go back. Here. Okay. So this is the first axis. This is the y-axis. What I want to do now is just duplicate that, rotate it by 90 degrees. So if I shift and click rotate, as you can see, I can rotate it easily to 90 degrees, because if I just, let's say I want to rotate it by 90 degrees, guys, let me show that. If I rotate it like that, as you can see, it goes degree by degree. So it's a little bit hard. I can still do it, but it's a little bit hard. If I click shift, it gives me less options. So it's easier just to rotate it to 90 degrees. So what I want to do now is align those two like that. Okay, it's not aligning. That's weird because I have 1 millimeter. Okay, let me click here.
Marcus, we do have a question in the chat room. He asks if she can change the rotating axis. By default is in the middle.
Let me hold on a minute. Let me read that.
Yes.
Can I change the rotating axis? I don't understand the question here.
I think she's asking if she can rotate by the edge, so she can actually shift it on a different axis. I think it's possible for the things in Tinkercad. You have the option to rotate in the 3 axes too.
Like that.
Yes. Yes, I think that's the question.
Or maybe she's asking because she says by default it is in the middle. Okay, maybe the question may be that maybe you want to rotate it from this point here, from the end point here.
This is the question.
Okay. So the answer is no. Tinkercad is a newbie designing program. For all I know, there is no option to rotate it from let's say another point. Generally, in more advanced design programs, yes, you can do that. You can actually find a point and rotate an object depending on a point and on the orientation. But since we are on a newbie program and starting to design, this is not an option here. So you will need to rotate it and then still try to place it appropriately. So let me continue. So we have the outer lines, the X and Y axis. What I want to do is also put a wedgie in order to make it more beautiful, and redimension it to 5 by 10 by 6, like that. No, that's not what I wanted to do. It's 10 by 5 by 6, like that. Okay. And now I will do the dummy placing. As you can see, I can click on top and place it like Lego. So there is no need to try to align things right now. We want to do fast operations. So I will just drag it, put it here. Okay. And now I have two beautiful X and Y axes. And what I want to do now is design my inner lines, the lines that are going to refer to the numbers. So I drag out a cylinder and I will rotate it. I will rotate it by 90 degrees. Again, like that. And again, reshape it. I will reshape it to 120 again by 3 by 5. Again, guys, 120 by 3, and the height is going to be 5. So what I want to do now is place it appropriately here, like that. And now I can duplicate. What I want to do, since I placed it here, I want to hide my red outer line and start duplicating this one. Shift click and duplicate it 10 millimeters away from the previous one. So now I don't click anywhere else on the on the workplace. I just start clicking duplicate. Maybe that's fine. This is fine. All right, so I have my inner lines and I want to do the horizontal ones now. So I just duplicate again, rotate by 90 degrees, like that. Again, place it, sorry, let me show it again. click on top, so you can actually view exactly where you want to put it. Click here, place it appropriately. Hide my outer line. And start duplicating. Again, 10 millimeters away. And click duplicate as many times as you want. So I will just delete the last one. And when I unhide them, now the diagram starts appearing, as you can see. All right. So because I don't like this one here, the outside part from the red, what I want to do is hide the wedgie, hide the red one maybe, and just lower the height here, like that. Okay, so now I don't view this anymore. All right. Let's make the base. So the base, guys, is the same way I did with a map. I will just make a big base. Let's say that the base is 170 by 150. What happened? 150, like that, by height of 2, let's say. And now I will place it appropriately here. There's something I don't like on that. Let's make it 150 by 170. Okay, this looks much better. Place it appropriately, like that. Sorry. Change the color because red is too much. And there it is. There it is. It's very close to the end design, as you may understand. But what I'm missing now is the holes, the pins, and the X and Y axis, and also the numbering. So let's do that. Let's start creating the holes. I will drag a whole cylinder like that. And I want to change the dimensions of the cylinder to 3 by 3. The height doesn't really matter right now because I will create a hole which will go through all of my design. So again, I will go on the top and place it appropriately on the top like that. What I want to do now, sorry, again, I am on top right now. What I want to do is duplicate the whole cylinder, and the same way I did it with the lines, I do it with the holes and start duplicating like that. Done. All right. So I also want to, right now, what I want to do is transfer the holes 10 millimeters up this way. So you may find a problem here, guys, because when I try to click on each one, I may click on the lines here, I may click on the box. So what you may want to do here is hide all of that. Just hide it like that. Hide everything except the holes. Maybe the wedgie too, why not? And now duplicate the holes and click duplicate them 10 millimeters up, and again start duplicating like that. And like that, what I will do now is I will group them all together so I can, when I click on one of them, I also click on all of them because now they are one object. Like that. And now I can unhide my diagram. Oh, what did I do? Wait a minute. Sorry, guys. I think I ungrouped instead of unhiding. And also the program stopped working. Okay. Okay, no, it's fine. Let me unhide everything. And as you can see now, every hole is on top on every cross of every cross. So if I just group everything all together right now, if I just click Control and group, now this is actually going to take a while. So maybe if you have a question, just write it down on the chat and maybe I have the time to answer. And let's all wait for the end design. Oh, it was much faster than I thought. What I want to do here, do you remember that, guys? I can actually click on multicolor here and still I have one object, but I can see them on separate colors. So it's much better for the eye. And now since I have the holes, I also need to make the pins to put them on the holes. How do you do that? You just drop a cylinder and instead of 3 by 3 that the hole was, you make it 2.8 by 2.8 so it can fit to the hole. And let's say that we want to put a height of 5. Okay, let's do it 5. Like that. Now I will drag a sphere that I want to put on the top of the cylinder. And I want to do it 5 by 5 by 2 this time. All right. And now how do I put the sphere on top of the cylinder, guys? How do I do that? We talked about the work plane tool. And what I can do with the work plane tool is click here, find the top of the cylinder like that, click on the top of the cylinder. And now when I click to my sphere, to my half sphere, when I click D, it goes on the work plane. So I just drag it here like that. And now I'm on the top of the cylinder just by clicking D. Or if you don't to click D, again, you can move this with your manually with your hand. But when you click D, you just put it on top of the work plane as I showed you on the previous webinar. So now what I want to do is align them together. So I will just leave my work plane tool by clicking anywhere else. So I'm back on my work plane now. And I can align them with the align tool. Just click on both, click the align tool. And of course, I don't want to align them by height because this is what is going to happen. I don't want this to happen. What I want to happen is align them on X and Y axis like that. And there it is. There is my pin. I have a pin now. I can group it. And I have a pin now. Like that. And you can duplicate it as many times as you want in order to print it. Like that. All right. Now this is basically your board, guys. You're done. You're already done. You have designed a 3D diagram. Now what you can do is go on the either either go on the design starters, and here you can find, I think that we haven't talked about this library. So let me spend a minute to talk about this library here. So this is a new library for Tinkercad. It wasn't used to be this way. So let's say when you are starting designing, this is what comes up. The basic shapes comes up, but here you can find a lot of things and drag them inside your prints, guys. So maybe you can click here and find your creations. Okay, I haven't created a shape, but you can actually create a shape and drag it as you drag a box or a cylinder. Maybe you have some favorite designs here and you don't search them again and again to drag them. And from here, from the basic shapes and below, there's a lot of things to find. Okay, the basic shapes are what we talked about, except the text that we're going to talk about in a minute. The design starters, here you can find more things like the geometric designs, like this one, like this one, like this one, like this is, which is very weird. That's a very weird design here. We can find letters and numbers. Most of you did because you designed the clock. Or you can find creatures like the astrobot that we talked about, or a weird doll of Elvis Presley, vehicles and machines, and so on and so on. So you can browse on that, find things, redesign them, maybe gain some ideas of what you can 3D print. Okay, let's go to the design starters for now and find our X and Y letters because we want to put them on the axis. This is the X. I will just drag it. And this is the Y. So I will put the Y here and the X here. And maybe make that. No, that's fine. Okay, so this is it. Now, if I want to number it, the best way to do it is by going to the basic shapes, drag the text like that. Instead of just dragging the numbers 1, 2, 3, and so on. And here you can, on this board right here, you can change the text. As you can see, it writes text. You can change the font. You can change the height, the segments, everything. And what I want to do is write 1, space, space, 2, space, space, 3, space, space, 4, space, space, 5, space, space, 6, and so on, like that. Now I can reshape it. Okay, that's not good. Okay, now I can go on top again. Reshape it like that. Okay, that's a good one. See, and I have already numbered. And again, you can manipulate it as if it was an object, like that. Okay. So now you have a diagram, numbers that visually impaired students get touch and understand how they correspond to its line. You have pins that you can put to create the diagram. You basically have everything. Everything you need for a visually impaired person to start understanding plotting diagrams, and also you can of course you can always make that even bigger. And let me hide that. Nope, sorry. Okay, like that. Maybe you can do the minus part, the minus y or the minus x, make that bigger. Now, the only problem that I can see here is that it's very small, because it's 15 centimeters by 17 centimeters. This is very small for a class, let's say, to have. So maybe what I want to do is, instead of 150, I make it 300. But now what happens is that it's very big for my printer to print. So what do I do? What do I do now? Basically, the only thing that I can do is cut my design and then glue it, the same way we did it with the Astrobot. So I will do it really fast this time. I will just make a box like that, duplicate. See, I have 171 millimeters length. So I will just go 171. Okay, now I will cut it in two. Okay, sorry, I will again try to take this, duplicate. Why that happens? That's so annoying. Okay, that is duplicate. Okay, there's a problem here, and I don't know what's happening. Duplicate. All right. Since it's a 8:15, I will not try to do that now. You saw it with Astrobot. There is no need to do that again. Basically, what I was going to do is cut it in 4 quarters. So let me just showcase. Cut it in 4 quarters like that. And then you can download each one separately, have 4 STL files, the same way we did here. You can, let's say I want to click here. As you remember, let's say that what is happening? Okay, let's say that I want to export here. I just click select only the selected shape, click STL, and then download all 4 quarters. Okay, guys, and print them one by one. So this is a 3D diagram. I will stop because I want to show something that will take approximately 5 to 10 minutes, maybe less. So Yuli, what do you think we should do? Should I do the next design and then stop for the questions, or wait for the questions now?
Well, if there are questions, please write them down.
Okay.
Because we're like 10 minutes before 12 minutes before the end of this webinar. So let's just take a break, because this was a lot that you designed.
Mm-hmm.
Okay. I see no questions. I think if someone had one already, it would be out there. So you
Okay.
can continue.
So let me show you the next design, which is easier than the diagram. It may look a little bit complicated, but I assure you it takes, when you know the program, it takes less than 2 minutes to design that. So this is a nameplate, guys. For a visually impaired person, this is, well, you do it mostly with kids when they try to understand how to write their name. Imagine a paper here on the work plane, and the holes here on the M, on the A, they guide the kid to write down their name, and then on the bottom they can start writing down their name without the help of the guides. So how do I do that? Let me do it. I just drag a box. Just say make a base the same way I did the previous bases. Let's say 150 by 150 by 3. Okay. So I have my base, and I will drag the text and write down the name of the kid. Let's say that the kid is called John. Like that. So, okay, this is a weird font. I would choose this one because this makes more sense and it's much easier. So you can reshape the name of the kid. And now I have my text. I don't want it to be solid though. I want it to be whole. So I make it a whole. I group them together. And now I have the name of the kid as a whole. The same way that the person who designed the clock did. So if I go back to the clocks, real fast because I have no time. So if I go fast to the back to the clock, this is the way this thing happened here. This is the same way you can write down things. You can make them wholes, write the text, make a whole, and do something like that. This is the same logic here. So basically, just by creating that, we're done, guys, right now, because the only thing you need to do is place appropriately some boxes here, like that, like that, like that. Maybe fix them a little bit. I want to be fast because we have no time. So, okay, I'm really sorry if it doesn't look perfectly aligned. In any case, this is what you do. And again, group them all together. And there it is, guys. You just did 3 things. You placed a box, you made it a base, then you placed text and made it a whole, and then you placed boxes and made them whole. And there you have it. There you have another print that you can use for children to teach them how to write their name. So this was our second design. It was a little bit, let's say, easier and understandable, I hope. So I will stop here. Maybe wait for some questions. In any case, I think that we don't have any more time. Is that right?
Yes, it's right.
Okay. So I will stop here the today's course. This is basically, guys, what I wanted to talk about today. Whatever you want. Yes, tell me.
Thank you.
What I want to say is that whatever you want to ask anything, maybe Yuli can send you my email or whatever, and I can answer any questions or send you instructions or videos so you can do your own designs.
Good. So if you have in mind some projects, some designs you want for your students, and you really want to start, because we have all the Christmas break now, and maybe you want to start designing some things, and you have questions, again, into our email, you can send all your questions. I'm writing down the email as I speak, and I will forward it to Marcos again. Marcos, if you can write your email if you want to.
Of
It's
course.
okay. Because at the end of this webinars, you will have to try and do some work with your students. Maybe you are now at that point that you want to start designing or experimenting with Tinkercad and anything, so you can ask us. We have already placed the link for the evaluation form to the chat room, but this will pop up as soon as the meeting is over. So you will see it. Marcos, if you please stop sharing your screen.
Yes, of course.
Thank you. And after we have this webinar uploaded in the website, we will send you the questionnaire for this webinar. Are there any other questions? Is there something yet that you feel that you really need to see again in Tinkercad, or something you think we missed and we didn't go through? Okay, I see nothing. Do we get homework, Marcos, at this point?
No, I think we are we were
Homework free.
pretty impressed with the clocks, so we don't need to retest them.
Okay.
What we have is the classic 10 questions questionnaire.
Yes, good. So we're ending the recording. Let's see. Good.